We're going to start with our chi-square goodness of fit test. Our test statistic for chi-square goodness of fit test is the summation of our observed frequency, which is denoted with F sub I, minus our expected frequency, which is denoted with a capital E sub I, squared, and divide all of that by our expected frequency, and add all of them up for each of our instances. Now, the first thing we need to do is define our hypothesis. So our null hypothesis is that all frequencies are as expected, and our alternative hypothesis is that something is different. And we're going to reject our null hypothesis if our chi-square is greater than our chi-square point, which we're going to get from our chi-square point table. So let's take a look at an example. In this scenario, we're going to be looking at microwave oven brands between two different cities. We're going to look between Cleveland to see if our projected sales in Cleveland are the same as what they are in Milwaukee, for example. So in Cleveland, we're expecting brand 1 to be about 20%, brand 2 to be 35%, brand 3 to be 30%, and brand 4 to be 15%. So if you add all of those up, they should equal 100%. Now in Milwaukee, we actually have some numbers to compare it to. So in Milwaukee, our brand 1, we had 102 sales. In brand 2, we had 121. And brand 3, we had 120. And let's say in brand 4, we had 57. And this is Milwaukee. We'll abbreviate that. Okay, so these are our actual observations, and these are our projections. So how are we going to determine this? We're going to take our chi-square goodness of fit test statistic, of course. So for a hypothesis perspective, our null hypothesis is that brand 1, or P sub 1, equals 0.2. P sub 2 equals 0.35. P sub 3 equals 0.3, and P sub 4 equals 0.15. That's our null hypothesis. Our alternative is at least one is going to be different. So the first thing we have to do is figure out our E so we can plug it into our test statistic. So first thing we're going to do is add up all of these because we need our total N. We don't know what that is just by looking at this. So if we add up all these numbers, we'll get 400. So for each of these, we need to take and calculate our E. So we're going to take 400 times our 0.2, and for brand 1, we're going to get 80. For brand 2, we're going to get 140. For brand 3, we're going to get 120. And for brand 4, we're going to get 60. If we add all these up as a double check, we'll also get 400, which is our total N. We can never have more than what we have. So this is our E for all of our Cleveland data. Now that we have our E sub I and our F sub I, we have our observed and we have our expected frequency, we can go ahead and calculate our test statistic of chi-square. So all we need to do is plug in our numbers. So the first thing we're going to do is we're going to start with brand 1, which is going to be P sub I. We're going to take our F sub I for P1, which is 102, minus our 80, which is our expected for that one, squared, divide that by 80. Then we're going to repeat that because remember, this sigma represents plus. We're going to add everything together. So we're going to repeat that for all 4 brands. So the next one is going to be 121 minus our 140 squared divided by 140. We're going to then add that to our third brand, which is going to be 120 minus 120 squared over 120. And last but not least, we're going to add that to our fourth brand, which is 57 minus 60 squared over 60. We get all of that, and if we do all the math in that, we should get 484 over 80 for our first one. We're going to add that to 361 for our second one over 140. Add that to 0 over 120, and then add that to, calculate that out, we get 9/60. We work all of that out and we get 8.7786. Now this right here is our chi-square. So then we take that chi-square and we compare it to our chi-square point. So we're going to pull up the chi-square table. So on the chi-square table, we're going to look up the alpha in relation to the degrees of freedom. So our n here is 4. Degrees of freedom is we're going to subtract 1. So we're going to look up 3 degrees of freedom on our table, and we're going to do a confidence interval of 5. So our alpha is going to be 5. And on our table, that comes out to be 7.814. Now, because our chi-square is 8.77 from this particular scenario, and our chi-square point is 7.814, our chi-square is greater than our chi-square point, so we're going to reject our null hypothesis.